Men, and I use the term loosely. Today's a big day around here, I guess, kind of. The frame is back from the powder coating guy, along with the other parts I gave him. So there's no reason this whole motorcycle can't be put back together. So let's get started. And the first thing I'm going to do is put the kickstand on, because it's easier to do when you can reach the bottom of the motorcycle. Here's where I'm at. Put the back motor mount bolts in just loosely, okay? Went around to the front over here, put the motor mounts on, put all the bolts in while the back were loose, got it all lined up, had to wiggle it and jiggle it and cajole it around. But basically these go in and out of there pretty easily now. This one's a little bit binding, but you know, it didn't take a lot of force to get these in. You want them to go in without really binding on anything. So then I went around and I tightened the rear ones. The front ones are all in, and now we could tighten these down. Okay, I got some pistons to install. These things were bored months ago. The easiest way I find to get them in there square to check ring gap is to put them in there sideways, rotate them around, and then take your piston and just push them part of the way down. I've done enough of them, I could tell by looking at them that that ring gap is probably bigger than it should be. But you know, I've never run into trouble running them bigger than they should be. I've run into trouble running them smaller than they should be. So I'll take that. I like to put the rings on as I go. Yeah, I know, I don't have a ring expander. I do stagger them around. Looks good to me. I like to put one clip in before I put the pistons on the rods. The other piston and pin, the pin slipped in without having to heat the piston up. See if I get lucky again. Yeah, I'm going to get lucky again. Okay, time to put the pistons on the connecting rods. As it turns out, these pistons just happened to be sized so that I could slide the piston pins in by hand. Usually I have to heat the pistons up, so I'd be doing this with actually with an UV glove on to handle the hot pistons. These do go in most of the way. They're a little tight near the end, so I'm going to grab a drift or a pin punch to shove them in the rest of the way, just to make sure they seat up against the piston pin clip on the far side of the motor. Alright, I'm going to try to put some piston pin clips in on camera. You got to put a bib on it so you don't drop them in the crankcase. They have gone flying across the room on me. For that reason, I keep some spares on hand. That went in too easy. Let's try this one. You do need to make sure they snap into the groove. Every once in a while, I run across them that don't want to snap in unless you persuade them a little bit. So I got the cutouts for the intake valve facing the right way. Everything's been checked and rechecked. Let's take a last look down in the crankcase. This case has been open for a while. Make sure no rodents have crawled in there and died. And do make sure the gaps are staggered. All I'm primarily concerned with is making sure they're not on a thrust face. That's really all I'm looking for. Okay, cylinder is smeared up with oil. Can be a little tricky. One's on. All right, let's make sure it still rotates. Smooth as a baby's butt. Good to go. Two's on. I really like the style of the cylinder base bolt for some reason. I just like them. All right, let's make sure it still rotates. Nice. All right, we're gonna pop a head on. Both sides of this have been liberally sprayed with copper gasket adhesive. Just going to put one bolt in for now. Another gasket sprayed with copper gasket adhesive. Just putting one bolt in for now. Going to see if the alignment of the intake manifold can be improved any by shifting the heads around a little bit. I know people make a big deal about this a lot of time, but frankly, it really doesn't seem to make a lot of difference in the end. Anyway, that's about as good as they're going to get. Let's put the rest of the bolts in. They all get a little smear of anti-seize. On a stock frame, you would not be able to get the rocker box in unless you bolted it to the head first. On this frame, there's plenty of room. Back when I was getting the cylinders ready, I chased all the head bolt threads to make sure the head bolts would go in easy. If you got a head bolt that you can't run down with your fingers, when you do torque it, you're not going to get a correct value. This one. This two. Do them in 3 stages. 35, 50, and 65. Crisscross. And 65. These are nasty old Harley head bolts. I like them. I've used some aftermarket head bolts that won't hold 65 pounds of torque. They snap off. And I'm going to go around one more time at 65 just to insurance. Good to go. All right, we're gonna pop some rocker boxes on this thing. You know, herein lies the problem with chrome. Chrome does not go on easily, well, evenly. These rocker boxes obviously have been powder coated glossy black, but you know, the surface was irregular. I tried to flatten it out, and you know, chrome, I hate chrome. Rarely will I chrome something on an engine myself. I may put some Permatex on here just because anything that's been chromed is likely to leak, in my opinion. Okay, let's pop a rocker box on. On a normal stock frame, you won't be able to do this. But on this frame, there's plenty of room to get the rocker box on over the valves. Popping the other rocker box on. Front one is easy, plenty of room. I used Loctite 518 on the rocker box side of the gasket. The cylinder head side of the mating surfaces is nice, real nice. It's just this fucking side that was chromed. Adjust the tension on the neck bearings, and basically what you do is you tighten the big nut until it bottoms out. And that's pretty much right there. The front end should be pretty stiff, and it is. And then you want to back it off a little bit. You don't want to feel any bearing drag in there. That's probably good right there. But you know what? I'm going to do it again just in case something was hanging up. Tight, can barely move it. And that feels good. So the next thing I got to do is finalize the mounting for the risers. And I got here some half inch 20 hardened steel rod. This is not that cheap shit you find at Ace. This is from an industrial supply house. It is grade 8. So I want to go all the way to the bottom of these holes. And that is about 2 1/4 inches. plus I got a 1/2 inch spacer I got to go through, so that's about 2 3/4. I measured the depth of the threaded holes on the handlebars, and shit, I can't even get to the bottom of those holes. So let's go for at least another inch of thread in there, so that will be 3 and let's just call it 4 inches. So we're going to lop off 2 4-inch chunks of grade 8 threaded rod. All right, let me see if I could do a decent job explaining why I want these studs to go to the bottom of the holes in these risers. I've marked off an inch here. The rule of thumb is that 6 threads is what you need for maximum strength, okay? But anyway, so I thread an inch into here. Okay, there's my inch. I then take this riser and I thread it into the springer. Well, maybe I get down in here 3 or 4 threads and I hit a burr, and this threaded rod quits turning, but yet I continue to turn the riser to tighten it in. Well, now the riser is tightening on the stud, but the stud is not being driven into the springer. So the result might be that I end up with just a thread or 2 of engagement in the springer, and that's all that's holding the handlebars on. Whereas if I run this to the bottom of the hole, you know, it doesn't need all that thread engagement. But once I get to the bottom of the hole, as I continue to turn the springer, I know that the threads on this rod are being driven all the way in. So the reason I'm going to the bottom of this is primarily a safety consideration, not to ensure I've got good thread engagement on this side of it, but that I end up with good thread engagement on this end of it. I hope that makes sense to you, but I regard this as very important that the handlebars don't fucking fall off. That was almost too easy. All right, remember a while back when I put the wheel on and I said that was almost too easy? It was. I put the wheel on, tightened the axle nuts, and I had overlooked the fact that when you tighten the axle nuts up, that the brake stay or the brake anchor could not rotate. And on a Springer front end, as the Springer bounces up and down, this thing needs to be able to rotate. So the solution was to remake the aluminum spacer out of steel and put a shoulder on it so that the stay had something to rotate against or around. The shoulder is just a little bit longer than the anchor, so that when I tighten the whole mess up, the inner spacer will tighten up against this part of the spacer, and it'll leave some clearance in there so that this could rotate. So anyway, let's put the front wheel on again. Okay, I cheated a little bit. I didn't take the wheel all the way off. I just left it hanging there to make this all a little bit easier. So hopefully we'll shove it all in there and everything will be good this time. Dare I say, that was almost too easy. All right. Wheels on, it rolls, and the brake anchor rotates around the axle just like it needs to. Good to go. A little 3-hour delay. Had to machine the parts. Okay, this little pile of stuff is the V-twin point conversion kit. This bike had on it originally, I think it was a CompuFire electronic ignition. And, you know, there's really no way to bench test those things that I'm aware of. I'm sure that people who make them can bench test them, but I can't. I wasn't too optimistic about it working because the back of it had been all torn up by flyweights and springs that had broken and come loose and ripped it up. This came with this kit. I don't remember how much it cost. But anyway, everything you need is here. One of the things they give you, well, they give you the eyelets, of course, to hook the wire up. I don't like those. I use these guys here. These are Aircraft MS spec connectors, which is what I use. And the Aircraft connectors, the Aircraft type connectors have a special crimper, which if you went out and bought it, this is the crimper right here, I'm sure it's several $100s. I bought this used many years ago at Oshkosh at the big, like 40 years ago at the big air show up there in August or July, whenever they run it. And, you know, it's, I'm sure, not certified for use on aircraft anymore because it has to be certified. But anyway, when you crimp a wire on with these, the requirement is that the crimp is sufficient so that if you pull on it, the wire will break before it pulls out of the connector. So I always use aircraft stuff. These automotive ones, these are junk, and I'm going to do a video sometime in the future about why I think they're junk, but they're junk. You may as well take the wire and, you know, put it in this thing and pound a couple of rocks together for as well as it works. But anyway, we're going to use aircraft stuff on it. One of the other things that I have found is that these points sometimes have a little oil on them or something. So I squirt some carb cleaner or something on just a piece of cardboard or stiff paper and rub it in there to make sure there's no preservative lube on these things, because if there's lube on it and they work, it'll burn, and if there's enough lube on it, they won't work at all. They'll be you know, insulated from one another, so you'll never get a good contact when they're supposed to be closed. But anyway, that's just what I do. You do whatever you want, but that's what I do. I put the eyelet under the spring. And I've seen some of these, they give you a open connector, a U connector. I don't use those because there is the chance it could come off. And even this is kind of flaky. So anyway, we're going to pop this in the bike. We're going to adjust the points on it, and then we'll set the timing and screw it down. Oh, one other thing I noticed. This has to sit absolutely flush on the end of the number 2 cam. And this pin, which is this stop pin in here, was sticking out proud of the surface a little bit. So I got a tiny punch and I just drove it in a little bit. So anyway, this goes on first, and it's idiot proof, you'll notice, because that pin sticks up and it won't go on all the way. You got to put the side with the flat on it alongside the little roll pin so that it'll drop on correctly. So we'll put this on, set the points, and we'll get that part of this operation done. And as I have grown to expect from import parts, this thing did not fit very well. It would fit in the hole, but it was bound up. It wouldn't quite go in all the way, and you couldn't rotate it. And of course, what I found was this being stamped out of a chunk of flat steel, the edge had, you know, those marks on it where, you know, the die shoves it through and it doesn't cut cleanly. So I just got back from the disc sander and I just put it up against the disc sander and rolled it around to smooth this edge up. It fits nicely now. It should be easy to adjust. It'll, you know, if it binds, it, you know, it doesn't want to move smoothly. But with it smooth it up, it rotates easily, so it'll make it much easier to do a precise job setting the points and the timing. All right, so we're going to try to adjust these. I've got my little doodad for holding them in the full advance position. Roll it around to full advance, clamp it down against the screw, and then you got to move the backing plate. Now I know, you know, the Generation X or whatever you're calling yourself these days, you won't like it because you can't do it from your phone, you know. This is the old-fashioned way. I know you can't see my voltmeter, but I got a voltmeter hooked up to the point lead, another lead hooked up to the crankcase. The points are closed. Resistance should be very, very close to zero, if not zero. Right now I'm reading 0.6 ohms, which is probably okay. I'm going to turn it to oral warning because I know you can't see the readout probably. So points are closed. You should be able to hear it beep. And we're just going to roll these around until they open. Oops, wrong way. Right there, that's it. The points are now open. My slot is in the window. And you notice just a little tension on the adjusting plate changes it a little bit. We're going to lock it down right here though, because I'm going to show you why I think it's still good. Alright, we're going to release the doodad because it hits the points when you roll it around. So we're going to rotate the engine one more time. Okay, number one cylinder's coming around on compression. We're going to put the holding mechanism in place. I'm going to rotate the engine until the line comes into the window. When the line comes into the timing window, the horn on the ohm meter should stop going off. Okay, horn stopped going off. I'll show you where the line is. There you go. Doesn't get much better than that. We're going to lock it down and call that good to go. I'm giving this cover one last look over before bolting it down, you know, blowing all the crud out of it that's accumulated from sitting around. And if you've watched this channel, you probably have heard me bitch about chromers. But anyway, I powder coated this and I powder coated it black. I did not mask off these inside edges at all, and I did that on purpose. There was quite a bit of powder coat that got on these edges. And this was chrome to begin with. And I didn't mask the area out because it was a pain in the ass. But the fringe benefit of that was this. After I got done powder coating it, I laid it on a surface plate, granite surface plate, onto which I had double-sided taped several sheets of sandpaper so that I could, you know, lap this thing in. And if you look over here, you see this black around here? This is powder coat that was not removed in the lapping process. And when they prep these things for chrome, they polish them on pretty powerful buffing wheels. Well, those buffing wheels remove a lot of material. And this black over here represents where that buffing wheel rolled over this edge and it took this metal out. So this low spot is still filled with powder coat. Same thing over here. And same thing over here. As I started getting it even, you'll notice that, for example, copper's exposed over here, but this is still chrome. This area in through here is all still low. And this is because of buffing these things. Chromers don't give a shit about the sealing surfaces. Chromers care about when you pick it up, you go, ooh, that looks nice. I'm sure this son of a bitch leaked oil, probably quite a bit when they bolted it on. There's areas all over here where you could see there's still chrome, but I've gone through the chrome and gotten down to the copper. Just to get it to this point took quite a while. I've gotten it as good as I thought it needed to be. Now, the other thing I do when I'm lapping them like that is I'll take a big fat black magic marker and I'll just cover it with marker and lap so you could see, so I could see the progress I'm making. And over here, some of this is powder coat, some of this is black magic marker. And over here, this area, this is black magic marker. These are areas that did not get sanded off when I was trying to lap it all flat and smooth. Anyway, chrome is the devil. If you're working on a motor, the last thing you want to do is chrome anything that has a bearing area, like the starter bearing used to go in there, or anything that has a sealing surface. The chromer will fuck it up on you and it will fucking leak. Anyway, this is ready to go. And I'm going to smear a rather thick layer of Permatex, what do they call it? Ultima Supreme. What do they call this shit? Nope, not that shit. That's former gasket. I'm going to use this shit. Ultra Black Gasket Maker. This stuff is the most oil resistant. You know, and I use it reluctantly because I don't like the idea that it could get sucked up and caught into an oil passage if it breaks loose. But the primary trans side of this thing doesn't have a pump and it doesn't have circulating oil. And these areas are less prone to damage from a piece of silicone floating around in there. Anyway, that's my lecture of the day. Okay, the screws and the RTV have been festering now for about an hour. The screws are snug, but they're not tight. I let the RTV set up a little bit, well, for about an hour. I want there to be decent film thickness. I don't want to squeeze it all out. So I let it set up for about an hour. Then I'll go put a final tight on the screws. And I will not put oil in this thing for at least 24 hours. You want to let the shit dry before you put oil on it. I know, you use it, you want to go right in, you want to see if the clutch works. Everybody gets in a hurry, but do yourself a favor, let the shit dry. I usually only put it on the primary side. You know, theoretically then I could take this cover off maybe once or twice without ruining the gasket and having to disturb the sealant. This screw down here, actually this nut is not backed up with anything. So you tighten it down, you're pulling the case in, but there's nothing backing it up, so to speak. You will crack the case, and I've seen plenty of them cracked. If this is leaking, the solution is not to tighten it up because you'll just break it some more. Anyway, be careful with this screw right here. Anyway, installed. That's done. All right, let's pop this brake back together again. Beautiful. Don't get much easier than that. All right, let's put this wheel together. There it goes. All right, got my two wires run up through the fender. So, time to start stuffing this wheel in. Needs a little more persuading. I'm not sure I'd engineer this the same way. I thought I was being real clever putting the axle adjusters on the outside of the plates because I got problems with them on the inside hitting the brake arm. But I don't know. I don't know if I'd do it the same way again. It makes getting the wheel off and on kind of hard. Anyway, wheels on. Men, and I use the term ever so loosely. The KHK project was finished 3-4 weeks ago, and since then I have been absolutely busting a nut to get this bike done. This is a 77 XLH that my customer wanted turned into a rat rod. You may notice the gas tank, the oil tank, and the rear fender are all unpainted. He wanted it that way. His idea is to let it rust a little bit, and when it reaches the desired level of patina, he wants to maybe coat it with boiled linseed oil or something. You may also notice that it has a drive chain Kickstarter pedal. It has a drive chain sissy bar. The taillight is welded into a old drive sprocket welded into the sissy bar. You may notice that it has a drive chain license plate frame. These are all mods the customer wanted. So he's paying for it, he gets it. Coming around down here, the bike has a hydraulic clutch. Seemingly, it works fine, seemingly. This bike has no miles on it right now at all. As a matter of fact, it hasn't been started yet. But anyway, coming around, unpainted gas tank, Pawco front end. The disc brake was transplanted off of his, 77 front end onto the Springer. It's got a kind of a beat up old headlight I had laying around, and the chrome was intentionally scuffed and sanded off. That's the way he wanted it to be, so that's what he got. Anyway, last night I tried to start this up for the first time, and of course it would not start. It's got a new battery in it that was dead. Probably in the course of wiring it up and testing things out, I guess I probably left the key on. Anyway, charged it up overnight. It's holding 13 volts. We're going to shove it out the door and try to start it up for the second time. So hopefully it will work. A lot of you guys were disappointed in the KHK videos in that you didn't get to see an engine running. Well, I'm doing a video on this bike, on the construction of this bike, and hopefully it'll start up and you'll get to see this one run at least. Anyway, let's shove it out the door and see what happens.